Hi guys, welcome. It is Math 6 Day 8. So we should have just gone over the review, and you should have the testing window open for that. So the review we did in class, there's not a video for that. So if you didn't have a video for a day, that was intentional. So now we're going to be looking at lessons 31, 32, and 33 today. So let's go ahead and get our books out, and this is on page 164. We're looking at area of rectangles. Right, so again, a rectangle is a quadrilateral with four 90-degree, four square corners, four 90-degree angles. So a square is technically a rectangle, but not all rectangles are squares. So we watched that video with the subcategories, where we can classify into multiple groups. So again, this probably isn't brand new to you, which is okay, but we have a rectangle right here. Again, if we're told it's a rectangle, we may or may not be given the little square symbol in there to indicate that it's 90 degrees, but we can assume that it is. So we know opposite sides are going to be the same. So 40 up top here and 20 on the side here. So that's the nice thing about rectangles is we can be given one side and pair it with the other one and same thing. So as long as we're given the length and the width, at least two sides, then we can find the perimeter and the area. So perimeter, we just add up all of the sides. When we're finding the area, we multiply length times width. And that's a pretty simple one to remember. It should be on your reference sheet. But when we come to our area, and highlighted word there may be new to you, area is if we were to fill up this two-dimensional shape, that's what we call the area. And that we're going to operate in square units. So it may be square centimeters, square inches, square feet, square yards, square miles, whatever it is that we're talking about. In a coordinate plane, we call it square units if we're given a polygon and we find the area of it. So it's not just area of a rectangle, it's area of any shape, even surface area down the road. We use square units. Okay, so if we have this square that is 8 feet wide and 12 feet long, again, length and width, sometimes we call it base and height, like in a quadrilateral or in a parallelogram or even a triangle, we use the terms base and height. We can use that interchangeably. It's just with a rectangle, for whatever reason, we use length and width. So 8 feet wide, 12 feet long. So what you can do is you can visualize these different squares. There's going to be 8 running this way and 12 running that way, and then everyone filled in accordingly. So you could visualize it that way. If there's 1 square foot tiles, these are all 1 square foot, 1 by 1. And how many could we fit in there? So we could go in and count them. We could draw this out, or we could just use length times width. 8 times 12 equals 96. So there's going to be 96 tiles. Or we could say in terms of square feet, there's going to be 96 square feet. Since each tile was a square foot, we're going to need 96 of them. This rectangle, 8 and 4, well, 8 times 4 is 32, and then square centimeters, or we can use pull up my whiteboard. Maybe. Okay, there we go. What we're looking at. Okay, yeah. So we have square centimeters. So we can spell out square centimeters and write it out if we want. And we know cm period is short for it. So more commonly, we'll do our centimeters, and then we'll put that exponent. We haven't talked a lot about those, but an exponent is this number in the upper right-hand corner. And this means to the power of 2, or we'll usually just say squared. So this can also mean square centimeters. You can write out square centimeters as Q period, cm period, or use this. So like inches squared, square feet. Okay, so when we're working with area, that's what we're going to be doing. Right. All right, we'll do some of these practice set problems when we return and meet in class. Lesson 32, we're looking at expanded notation and elapsed time. Okay, so expanded notation is simply just another form that we can write. We'll get to scientific notation, we have expanded notation, a lot of different ways that we can write our numbers. Sometimes it just helps us. For this, we need to remember our place values. So 27,000 and 270,000, we're looking at those. Okay, so we have the ones place, tens, hundreds, thousands, and 10,000s place. So how we could write this in expanded notation, 2 times 10,000, because 2 is in the 10,000s place, and then 7 in the 1,000s place, and then we don't have to put 0 times 100 and 0 times 10 and 0 times 1. If it's just zeros after that, then we don't have to put anything in there. So as we look down here, the way we would write it, 27,000 is the same one as example 1, 2 times 10,000, put that in parentheses, plus 7 times 1,000. Again, then we don't need to include anything for our zeros, because if we then perform this and simplified this equation, we'd get 20,000 plus 7,000, which is 27,000. So we're not changing the value, we're just writing it in a new form. And then if we're given 5 times 1,000 plus 2 times 100 plus 8 times 10, okay, well, 5 times 1,000 is 5,000. 2 times 100, 200, 8 times 10, 80. So 5,000 plus 200 plus 80, 5,280 is what we would write. Again, a zero's in the ones place, so we don't include that. And we could always check our work from expanded to standard or standard to expanded by just making sure that this is equivalent to this, which if we punch that into our calculator, perform the calculation, it would be. Okay, time is one that's kind of unique because we have minutes and hours, so we're working with really technically 2 different units, and then we use this colon in between to separate the hours and minutes, and then, unless we're using military time, commonly we go, midnight, which is 12 a.m., and then we go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and then start over 1, 2, 3, 4. So it's kind of unique that we start at 12 and not 0, and then we go 1, 2, and then we start over again at 12, and then we separate morning, we call AM, and then evening times afternoon. Okay, 12, 1, 2, 3, we use PM. And then we don't have 99 minutes in an hour. It's another thing we got to pay attention to. We have 60 minutes in an hour. So we go 1 through 59, and then once we hit 60, we go over to the next hour. So for me, versus setting it up in an equation, a lot of times the easiest thing for me to do is just use my fingers and mentally kind of count out the hours from now until 9 a.m. tomorrow, or from the time you wake up until 7 p.m. or whatever. It just kind of counting out the distance between those, by counting out the hours and the minutes, that will help you out. But let's take a look at example 3. So Jason started the marathon at 7:15 a.m. We started at, again, it's a word problem, so always write down what you know, 7:15 a.m. He finished the race at 11:10 a.m. Okay, so we're going to start with our end time. And then our start time. And now again, 10 minus 15. It gives us a negative number, which we can't have negative time. He didn't run it so fast that he reversed time. So we need to take 1 from here and make this 10, okay, and then add it to here. But again, we're not adding 100, we're adding 60. We're adding 1 hour, which is equivalent to 60 minutes. So we're going to add 60 to 10. So this is now going to be 70 minutes. Now 70 minus 15, we can do that. And then we're left with 10 minus 7, which is 3. So 3 hours and 55 minutes. Again, I think for me, if I was doing this, someone was just telling me, hey, they're breathing really hard at the end of a race, they don't know how long it took them to run it, I would just say, well, 7:15, and then 8:15, 1 hour, 9:15, 10:15, and then 11:15 would be 4 hours, but he ended at 11:10. So then I would just subtract 5 minutes, and that would give me 3 hours and 55 minutes, just under 4 hours. So that's how I would do it. But again, write down what you know. You know when he started, you know when he ended. You can figure out the difference of 3 hours and 55 minutes. Okay, so we'll do the practice set for those when we return to class. Okay, and then lesson 33, the last one that we're working on for this video, writing percents as fractions, part 1. It says part 1 because we'll be doing this the entire year and into 7th grade, 8th grade. You guys are doing in high school. It'll become so repetitive that you'll kind of just do it without even having to think about it, which is nice. But for right now, it may be a little bit newer. So let's kind of slow down and look at what we're doing. So we're writing percentages as fractions. So again, we know 50% is equivalent to half. If I give you, you got 50% on a test, you got half the questions correct and half the questions wrong. 25 is equivalent to 1/4. But how do we make these into fractions? So we remember back to previous lessons, percent means per 100. So percent, 50 per 100. So we can write that as 50 over 100. And then 50 goes into 50 once and into 100 2 times. Just reduce down your fraction and you're going to get 1/2. Same thing, 25%, 25 over 100 reduces down to 1/4. Okay, so in Benjamin's class, 60% of the students walk to school. Write 60% as a fraction. Well, 60%, we're going to do 60 per 100. Okay, that's the first thing we do. And then we just reduce. Oh, I see they both end in a 0, so I can factor a 10 out. Again, you may see the greatest common factor right away, which is great. That's going to save you a few steps. If not, just keep reducing until you can't anymore. So I factored out a 10, and now I have 6/10. They're both even numbers, so 2 still goes into them. So 2 goes into 6 3 times, and into 10 5 times. So 60% as a fraction, as a reduced fraction, 3/5. Okay, so just start with your percent over 100. Okay, down the road, we'll work with percents that are greater than 100. Just turns into a mixed number. We'll also work with how to do these as decimals, which is actually a little bit simpler than fractions, in my opinion. But for right now, we'll start by putting it over 100 and then reducing down if we are able to. Okay. Find the reduced fraction that equals 4%. Again, 4%, we're going to do 4 over 100. Okay, again, just start with, you may see right away, oh, 4 goes into 4 and 100. That's great. You may start with 2 because they're both even numbers. Okay, divide both of these by 2 or factor 2 out. And that's what you got. And then, oh, that's still even. So I know 2 still goes into it again. Okay, so 2 goes into 50 25 times. So 1/25. Or again, like I said, you could have factored out 4 right away. Well, 4 goes into 4 once and into 125 times. You're not going to get in trouble or get a problem wrong if it takes you more than one time to reduce it. If you can see the greatest common factor right away and figure that out, it just saves you some steps. But if you need to keep reducing 2, 3, 4, however many times, that's fine. Just keep reducing until you can't anymore. 1 and 25, obviously, we can't reduce 1 down anymore. It's a prime number. 25 is not a prime number, but it doesn't help us out to break it down anymore because it's 1 over 25. So no common factors besides 1. So we would be done. 1/25. Okay, and then these practice set problems we'll go over when we return. So watch this video, and we will see you guys here before too long. Thanks.